Okay, let's unpack this. Today, we're embarking on a deep exploration, really, into the heart of a truly massive weather event. A storm that hasn't just commanded our attention here, but has, well, quite literally captured global attention with its staggering scale. Hurricane Erin. We're talking about a system so immensely vast. I mean, its cloud shield already extends a colossal 1,000 miles. Think about that. Reaching all the way from the, sun-drenched beaches of the Bahamas up to the cooler climes of New England. Just pause for a moment and consider that scale. That's an atmospheric influence covering more than 15 states. It's an astonishing footprint. As we speak, the calendar shows us it's Thursday, August 21st, 2025, and Erin is currently making its closest approach to the North Carolina coast.
Our mission for this Meteorology Matters deep dive isn't just to track its immediate movements, no. We're here to sort of peel back the layers of Erin's current behavior, to project its path and the immediate impacts it will have.
And perhaps most importantly, to meticulously connect the dots between such powerful, far-reaching events and, well, the larger climate picture that is undeniably shaping our world and the behavior of these storms.
Yeah, and what's particularly compelling about Erin, as you've highlighted so well, is not just its sheer scale, but how its very characteristics, its immense size, its rapid intensification, how they reflect these broader meteorological trends that are becoming increasingly vital for us to understand. We're going to be discussing information gleaned directly from the very latest forecasts, real-time observations from those incredibly brave hurricane hunters flying right into the storm, and of course, meticulous meteorological analysis. This confluence of data, it really allows us to paint a comprehensive and, dynamic picture of this formidable system.
Absolutely. Now that we've set the stage with Erin's immense scale, let's turn to its immediate behavior. What are the latest observations telling us about its current state and movement out there?
Well, currently, Erin is positioned around 34.2 degrees north latitude, 72.1 degrees west longitude. It is literally just past its closest point to the North Carolina coast. It's moving at a pretty brisk pace, northeastward at a clip of 15 knots, which translates to roughly 17 miles per hour. And despite having made its closest pass, it remains a remarkably powerful system. Estimated maximum sustained winds are still at a formidable 90 knots, or about 105 miles per hour.
Still a strong Category 2, then.
Exactly. Still packing quite a punch.
And we've had critical eyes on this storm, literally. The Air Force Reserve hurricane hunters, these, well, intrepid individuals who fly directly into the eye, they've been providing invaluable data, haven't they? What did their last transect through Erin reveal?
They have indeed provided crucial insights, yes. On their last pass, they measured 700 millibar flight level winds of 100 knots. Now, for some context for you, 700 millibars is roughly equivalent to an altitude of about 10,000 feet. And that's a crucial level for assessing the storm's actual wind structure. It's often less affected by surface friction than measurements closer to the ocean. So it gives us a clearer, more representative picture of its inner core strength and how winds are distributed within the storm itself. They also found that the central pressure had risen slightly to 945 millibars.
Okay, and a rising pressure means...
Well, in simple terms, a hurricane's strength is inversely proportional to its central pressure. So the lower the pressure, the stronger the storm. So this slight increase in pressure, while it might seem small, it's a subtle but important indicator. It suggests Erin's peak intensity may have passed, or at least it's starting a slow decline, maybe undergoing some structural reorganization. Visually, the low-level center of the storm is still deeply embedded beneath a vast 90 nautical mile central dense overcast. And this isn't just a visual detail. The central dense overcast, it refers to the tightly packed, circular cloud shield of deep convective clouds that typically surrounds the eye of a mature hurricane. It tells meteorologists that the storm's engine room, where all the energy is being drawn up from the ocean, is vast and incredibly well established. And that contributes significantly to its enormous size and widespread impacts, even far from the immediate core. However, we're also observing outer convective bands stretching a couple hundred miles away, and importantly, some recent erosion of clouds in the southwestern part of the circulation.
Right, so we have the slight rise in pressure, the satellite estimates perhaps being a bit lower, and this cloud erosion you mentioned. What does that collection of observations tell you about Erin's immediate future?
Well, if we connect this to the broader meteorological picture, that slight rise in central pressure, combined with some of the satellite intensity estimates being a little lower, and yes, the erosion of clouds in the southwestern part, it all points directly to an increase in what we call wind shear.
Wind shear, okay.
For you, our listeners, increasing shear basically means that the wind speeds and directions are changing rapidly with height in the atmosphere around the storm. Imagine a tall, perfectly formed spinning top, right? If you suddenly blew on it from different directions and at different heights, it would start to wobble, tilt.
Right, lose its balance.
Exactly. It eventually loses its tight, upright spin. That's essentially what shear does to a hurricane. It can really tear at a hurricane structure, making it less organized and generally less able to intensify further, or even causing it to weaken.
Okay, that makes sense. And what about its path? Where is it headed now?
As for its future track, the forecast reasoning remains quite consistent among the various weather models, which is good. Erin is expected to continue accelerating, making a pretty significant turn northeastward by Friday. This change in direction is because it's becoming increasingly embedded within the mid-latitude westerlies. Essentially, it's getting caught in those fast-moving west-to-east atmospheric currents that exist outside the tropics.
So it gets swept along, basically.
Pretty much. These powerful winds will propel it rapidly eastward across the Atlantic. The latest track forecast actually shows Erin racing across the North Atlantic, with its forward speed projected to peak at a rather brisk 35 knots. That's around 40 miles per hour in about 72 hours from now.
Wow, really moving. This naturally leads us to ask, will it get stronger? Given what you just described about the shear, it sounds like that window might be closing.
You're absolutely right to ask that. The critical query then becomes, will it get stronger? And the answer, fortunately, seems to be that significant strengthening isn't expected. The atmosphere surrounding Erin is becoming increasingly stable, and with that increasing shear we just discussed, the window for any further intensification is rapidly closing. We're looking at a period of slow weakening over the next 36 hours or so, which will then likely transition into a more steady, gradual weakening trend after that time.
That's genuinely good news.
It is good news for anyone who might have been concerned about it regaining its former Category 5 intensity. Its energy source is shifting, and its structure is just becoming less favorable for pure tropical strength.
Okay, so what does this all mean for those of you along the coast? Let's turn our attention to the key messages directly from the forecasters. Because despite Erin beginning to pull away from the immediate U.S. coastline, its sheer immense size means its influence is still incredibly far-reaching and vast. General warnings are currently in effect for life-threatening surf and dangerously powerful rip currents along beaches across a massive area. This includes the Bahamas, much of the U.S. East Coast, Bermuda, and Atlantic Canada. These dangerous conditions. They're expected to persist not just for hours, but for several days. It is absolutely crucial for your safety to follow advice from lifeguards and local authorities. Pay immediate attention to any beach warning flags you see. Seriously. And this isn't just about direct hits, it's really about the widespread impact of a truly gigantic storm system. Erin's sheer size is precisely what makes it such a serious threat, even when it's hundreds of miles offshore. Its tropical storm force wind field alone extends an astonishing 300 miles from its center. And the high-energy, dangerous ocean waves it generates, they're reaching over 1,500 miles from the storm's core. That stretches from Florida all the way up to Newfoundland, Canada. That's why we're seeing an unprecedented 15 states, from Florida clear up to Maine, currently under some form of alert for hazardous coastal conditions. The geographic influence is just remarkable.
It really is.
Yeah.
And delving deeper into this, what's particularly compelling here is how the storm's massive size translates into very real, localized, and incredibly serious threats on the ground. Or, well, on the coast. Let's maybe break this down into specific regional impacts, connecting the storm's characteristics to the observed and anticipated effects.
Good idea. Let's start with North Carolina, where it just made its closest approach.
Right. For North Carolina, specifically the vulnerable Outer Banks, we are currently seeing ongoing storm surge, flooding, and tropical storm conditions that will continue throughout today and into the evening. This storm surge, combined with truly large, powerful waves, is expected to lead to significant beach erosion and overwash. Imagine living on Hatteras Island, where Highway 12, your literal lifeline.
Yeah.
It's not just flooded, but overwashed, meaning layers of sand and debris are now covering the road, making it completely impassable in places.
Wow, that's isolation right there.
Exactly. It isolates communities, complicates any emergency efforts, and makes travel impossible for residents. Evacuation orders, in fact, remain firmly in place for Hatteras and Ocracoke Islands for good reason. We're talking about anticipated wind gusts of 40 to 60 miles per hour in the Outer Banks, combined with up to 4 feet of storm surge. And waves. Waves that could reach up to 20 feet.
20 feet? That's hard to even visualize the power of that.
It's immense. Like 2-story buildings collapsing onto the shore with every wave. That's the kind of destructive force we're discussing. And the highest tides, which will exacerbate these effects, they're expected this evening and will continue through Saturday. So it's prolonged exposure. And it's important to note the severity. The governor of North Carolina has already declared a state of emergency. They're taking this very seriously.
Understandably so. Okay, moving north. Virginia and Maryland.
Yes, zooming out, the broader implications extend north to Virginia and Maryland. Virginia is also experiencing tropical storm conditions. Wind gusts to tropical storm force are likely along portions of the U.S. mid-Atlantic coast. We are anticipating moderate to even major coastal flooding, especially tonight, stretching from Virginia Beach up to Ocean City, Maryland. For residents and businesses in these coastal areas, this translates to the very real potential for numerous road closures and significant inundation of homes and businesses nearer the shore. Beyond the flooding, you've got large, pounding waves of 10 to 14 feet, strong rip currents that can pull even experienced swimmers out to sea.
Very dangerous.
Extremely. And significant beach erosion, too. In the Chesapeake Bay area, that vast tidal estuary from Norfolk all the way up to Annapolis, Maryland, water levels could be notably higher than normal, up to 3 feet higher. That could inundate low-lying coastal areas there. We could even see up to a half-foot of flooding along the tidal Potomac River, potentially reaching into parts of Washington, D.C.'s waterfront. The National Weather Service in Wakefield, Virginia, they put it very starkly in their warning. I should quote this: "Dangerous shore break can throw a swimmer or surfer headfirst into the bottom, causing neck and back injuries."
Oof, that is incredibly vivid and sobering. It really underscores that even without direct landfall, these impacts are life-altering, potentially deadly.
Absolutely. It's not just about the storm center.
So how far north will these hazardous impacts really reach with significant force? What can communities in Delaware and New Jersey expect?
Right. The critical query then becomes, how far north do these serious impacts extend? Moving into Delaware and New Jersey, we're seeing the potential for 1 to 2 feet of water, inundating coastal and bayside communities, along with tidal waterways. That could make numerous roads impassable and severely restrict access. Dangerous surf is expected to slam the coastline, particularly today, Thursday, bringing immense wave energy. The worst conditions will likely coincide with the high tide this evening, though hazardous conditions are certainly expected to continue right through Friday. The National Weather Service office in Mount Holly, New Jersey, had a particularly memorable phrase for it. They just said, "The sea will be quite angry."
Quite angry, that says a lot.
It does. It signifies immense destructive wave power that can reshape shorelines and endanger anyone too close to the water. It's not just a poetic description.
Understood. And even further north, New York, New England.
Even further north, yes. Reaching into New York and New England, from Staten Island all the way out to Montauk, New York, and then up to Nantucket, Massachusetts. High surf advisories and coastal flood warnings are firmly in effect. Here, too, the primary risk is for life-threatening swimming and surfing conditions. Those powerful rip currents that act like invisible rivers pulling you out. And localized beach erosion, which can undermine coastal structures and dunes.
Yeah.
Wave heights and energy will peak later today, Thursday, and into Friday. We could see waves of 16 feet potentially hitting the south shore of Long Island.
16 feet on Long Island South Shore. That's significant erosion potential.
Huge potential. Think of a 2-story house collapsing onto the beach repeatedly. That's the kind of energy. It could cause significant dune erosion and coastal flooding, with maybe up to 2 feet of water inundating vulnerable waterfront areas. Further up the coast, say from Cape Cod, Massachusetts, up to Eastport, Maine, waves could reach up to 18 feet at the southern end of that stretch, gradually decreasing to around 10 feet toward the northern end, but still bringing similar dangerous swimming and surfing conditions and beach erosion issues.
And it doesn't stop there, does it? You mentioned it's reached beyond the U.S.
No, it really doesn't. Erin's immense reach extends far beyond the U.S. mainland, truly demonstrating its global influence. Bermuda, for instance, will experience dangerous 10 to 20-foot waves as Erin passes about 300 to 400 miles to their west and north. There's even the potential for rogue waves, those exceptionally large, unexpected waves that seem to appear out of nowhere, maybe reaching up to 30 feet.
30 feet? That's terrifying.
It's like a 3-story building of water crashing down. Unbelievable force. Squalls of heavy rain and strong tropical storm force winds are also expected for Bermuda from today, Thursday, into early Friday. And for Atlantic Canada, rough and dangerous seas are anticipated along the southern coastlines of Nova Scotia and Newfoundland from Friday into Saturday. Gusts to gale force are possible along the coast of Nova Scotia on Friday, and then the Avalon Peninsula of Newfoundland on Saturday. So this storm's influence truly spans a massive section of the North Atlantic, affecting countless communities even without making a direct landfall anywhere else from here on out.
So Erin is a truly massive storm, as we've detailed, but it's also evolving, and quite rapidly, into something fundamentally different. What's next for it? Where is it heading beyond our shores? This is where we start talking about its grand transition, right? Moving from a fully tropical system to a post-tropical one.
That's exactly right. The official forecast has, in fact, moved up Erin's transition to a post-tropical cyclone. They're now calling for it at 60 hours from now. Though some of the very latest guidance, based on the storm's current characteristics and the environment, indicates this could happen even sooner, perhaps within, say, 36 to 48 hours. This is a crucial shift in its identity, how it gets its energy.
Let's look at some key points from the forecast positions and maximum winds, just to trace its journey across the Atlantic. At 5 a.m. Eastern Daylight Time today, Thursday, August 21st, Erin was at 34.2 north, 72.1 west, still sporting those powerful 90 knots or 105 miles per hour winds. But by 60 hours from now, so that's Saturday evening, it's projected to be way out at 43.6 north, 48.7 west. Winds dropping to 65 knots or 75 miles per hour. And that's the point it will be formally classified as post-tropical or extratropical, correct?
Correct. That's the marker.
Okay. Then by 72 hours, early Sunday, it's forecast to be at 46.7 north, 40.2 west. Still a substantial system with 60 knots or 70 miles per hour winds. And even way out at 120 hours, that's next Tuesday, it's expected to be near 56.8 north, 21.7 west, still with 45 knots or 50 miles per hour winds. Still a significant force.
It really is. That trajectory shows it literally crossing the entire Atlantic basin. It's quite a journey. And what's particularly fascinating here, what the models are showing, is that even as Erin loses its tropical core and undergoes this post-tropical transformation, global weather models like the GFS and the European ECMWS, they're consistently trending toward keeping it remarkably large and strong as it continues its rapid journey across the North Atlantic.
So explain that extratropical transition a bit more. It loses its tropical heart, but doesn't just fizzle out.
Exactly. For our listeners, extratropical transition means the storm loses its warm, symmetric tropical core, which relies entirely on warm ocean waters for its energy. Instead, it essentially merges with a separate mid-latitude weather system. It starts drawing its energy now from these stark temperature differences found in the atmosphere outside the tropics' baroclinic energy, we call it, rather than just from ocean heat. But this doesn't necessarily mean it weakens significantly right away. In fact, its wind field can actually expand dramatically during this process. It could become an even more sprawling and impactful system covering a much wider area.
Interesting. So it changes character, but not necessarily loses all its punch.
Precisely. In fact, the National Oceanic and Atmospheric Administration, NOAA, has adjusted its wind radii and intensity forecasts upward for this post-tropical phase. That indicates it will continue to be a substantial system, capable of generating significant impacts across a very wide swath of ocean and eventually land. And if we connect this to the broader global picture, the remnants of Erin will be scooped up and carried by the powerful jet stream, those fast-moving rivers of air, high in the atmosphere.
Right.
They'll carry it straight across the Atlantic, heading directly toward Western Europe early next week. We're talking Monday and Tuesday specifically. Even as a post-tropical system, it's still expected to pack a considerable punch. It'll bring a notable risk of gusty, potentially damaging winds and large, dangerous waves, particularly to Ireland and Britain. Coastal communities there will definitely need to prepare for its arrival.
That's an absolutely astonishing journey for one storm system. But this raises an important question. How exactly did it get so big in the first place? It's not just powerful, it's geographically immense.
It's a truly remarkable transformation and a crucial aspect of understanding Erin. It really does raise that question, how did it get so big? Erin began as a more tightly coiled, albeit still incredibly powerful, Category 5 storm. But since then, its wind field has expanded to be more than, get this, 12 times larger than it was at its tropical peak intensity.
12 times larger. That's incredible.
It really is. Think about that for a moment. It's like a small, intense vortex suddenly expanding its influence to cover a massive area. Currently, hurricane-force winds extend a substantial 105 miles out from the center, and tropical storm-force winds reach out an astounding 325 miles from the center in some directions. This massive expansion is exactly why its impacts are so far-reaching. It's why we're seeing hazardous conditions so far from the storm's core, even when it's hundreds of miles away from land.
Right.
It's a testament to the storm's ability to reorganize and expand its influence, a characteristic often linked, actually, to these rapid intensification events we saw earlier.
Okay, this journey into Erin's life cycle, from its rapid intensification to its massive size and these far-reaching impacts, It brings us to an even bigger, more profound question, doesn't it? How does a storm intensify so rapidly? How does it become so massive? And why does it have such far-reaching influences across our planet? This is where climate science truly comes into play and where the dots, as you said, begin to connect very clearly. Think about this again. Overnight last Friday, Hurricane Erin ratcheted up from a Category 1 to a Category 5 storm. That made it one of the top 5 most quickly intensifying hurricanes on record. Its wind speeds increased by nearly 85 miles per hour in just 24 hours, peaking at an incredible 161 miles per hour. That kind of explosive growth is what meteorologists call rapid intensification, and it's a phenomenon we seem to be seeing more and more of.
And what's critically important here, what's truly fascinating, is how directly these rapid intensification events are being linked to global warming.
Yeah.
As Jim Cosson, a renowned hurricane specialist and climate scientist, formerly with the National Oceanic and Atmospheric Administration, put it so succinctly, and I think it's worth quoting again, it's a very easy set of dots to connect, pointing to a clear human fingerprint on these types of events.
A human fingerprint. That's a strong statement.
It is. He's telling us that the underlying conditions of our planet are changing in ways that make such explosive growth not just possible, but increasingly probable. Scientists identify this human fingerprint by using sophisticated climate models. They compare what happened in reality with simulations of a world without human-caused greenhouse gas emissions. And these models consistently show that the extreme ocean warmth needed for rapid intensification is far, far more likely in our current warming world. Daniel Guilford, another prominent climate scientist, provides a really useful analogy for understanding this whole process. He likens hurricanes to car engines needing fuel. The primary fuel source for these powerful engines is the ocean surface heat.
Right. Makes sense.
So as the temperature of the ocean surface goes up, that simply adds more fuel for these storms to utilize, allowing them to intensify more quickly and potentially reach higher peak intensities. This naturally leads us to ask, just how warm are the oceans right now?
Yeah, what's the situation?
Well, the answer is significantly warmer than historical averages. For over a century now, human-emitted greenhouse gases have been accumulating in our atmosphere, trapping heat within the planet's climate system. 2024, in fact, was unequivocally crowned the hottest year on record globally. By May of 2024, nearly a full quarter of the world's entire ocean area experienced what are called marine heat waves, essentially turning vast stretches of ocean into what some experts have described as bathwater.
Wow.
And our Atlantic Ocean, particularly in the main development region where hurricanes often form and track, it remains anomalously warmer than average. This warmth has led forecasters to anticipate a busier than usual hurricane season overall, and for the storms that do form, a higher potential for this kind of rapid intensification we saw with Erin.
So warmer oceans mean more fuel for intensity. What are the broader impacts of that increased fuel supply on storms like Erin beyond just wind speed?
That's a great question, because the impacts of these warmer oceans extend far beyond just the storm's intensity. They also mean a greater potential for more rain. Warmer air fundamentally has the capacity to hold more moisture. It's just basic physics.
Right, like a bigger sponge.
Exactly like a bigger sponge. So hurricanes forming in these hotter, more humid conditions can carry a significantly greater amount of rain. This leads to more severe freshwater flooding once they make landfall or even just skirt close to coastal areas. Often, it's the water, not just the wind, that proves to be the deadliest component of these storms.
So intensity and rainfall potential both increasing.
Yes. And if we connect this to the broader climate picture again, analysis from Climate Central, they're a science communication nonprofit specializing in synthesizing climate research. Their analysis suggests that human-caused climate change made the warm water temperature around where Erin formed 90% more likely.
90% more likely. That's a huge increase in probability.
It's a very powerful attribution finding. They use statistical modeling that compares the current conditions to a simulated world without human-induced warming, and the difference is stark. Their early estimate, using the same robust statistical model, also found that this extra ocean heat could potentially drive 50% greater damage, specifically from things like tidal erosion and coastal flooding in the affected areas.
50% more damage.
Potentially, yes. It's not a vague projection. It's tied to the specific, measurable increase in water temperature likelihood attributed to climate change.
And this ties into sea level rise as well, doesn't it?
Absolutely, it compounds the problem. This also includes the exacerbating impact of rising sea levels on coastal flooding. as polar regions melt and sea levels continue their steady, relentless climb due to both melting ice and the thermal expansion of the warming ocean waters themselves.
Right, water expands when it heats up.
Exactly. So that rising tidal baseline means that any coastal flooding caused by storms automatically becomes correspondingly larger and reaches further inland. To illustrate this, think back to Hurricane Sandy, which devastated parts of the U.S. Northeast some years ago. Analyses showed that the floods from that storm were 4 inches deeper than they would have been without the sea level rise that had already occurred by that time.
4 inches doesn't sound like a huge amount, but
But it can be critical. As one expert pointed out, 4 inches could easily be the difference between the bottom floor of a building being flooded catastrophically and remaining completely dry.
yeah, the difference between minor inconvenience and total loss for a homeowner or business.
Precisely. It highlights how even seemingly small changes in baseline conditions can have massive real-world consequences during extreme events. And finally, let's just quickly revisit something Erin did in its life cycle that contributes to its vast size. It underwent an eye wall replacement cycle.
Right, you mentioned that earlier.
Yes. This is a complex meteorological term, but basically, the hurricane grows a second larger eye wall around its original inner one. It's quite common in very intense hurricanes like Erin was. Now, while this process can sometimes slightly weaken the storm's absolute maximum wind speeds for a time, as the energy gets distributed over a wider area, it almost always makes the storm significantly larger in overall size. It spreads its impactful wind field over a much, much wider area.
Making it bigger, even if slightly less intense at the very core.
Exactly. And what's interesting, connect back to our theme, is that faster intensification, which is directly driven by that warm ocean water we've discussed, actually makes these eye wall replacement cycles more likely to occur. As Jim Costin emphasized earlier, and it really bears repeating, all these behaviors are ultimately linked to the warm water that these storms are sitting on top of. The water is warm because the planet is heating up.
It's a powerful and direct link.
It is a link we are seeing play out with remarkable clarity in storms like Hurricane Erin.
Okay, so as Erin barrels across the Atlantic, heading eventually for Europe, are there other tropical systems out there we should be keeping an eye on? What does the immediate future hold for the tropics? Or are we perhaps due for a bit of a breather after such an active period in this major storm?
Well, we are indeed monitoring 2 other disturbances currently in the Atlantic basin, though it's important to stress, neither of them currently appears to pose a direct threat to the United States. The first is a relatively large and, frankly, somewhat disorganized tropical wave that is approaching the northeastern Caribbean islands right now. The National Oceanic and Atmospheric Administration is currently giving this one a 70% chance of eventually developing into a tropical depression or tropical storm over the next week or so. It's expected to approach the Windward and Leeward Islands today, Thursday, and into Friday, bringing with it scattered downpours and maybe some gusty winds. However, the strong consensus among the computer forecast models is that it won't be particularly strong when it's in the vicinity of those islands tomorrow or Saturday. So that mitigates the direct risk there.
Okay, and after it passes the islands?
After that, it's most likely to take a northward path out into the open waters of the western Atlantic. While it may strengthen into a tropical storm over the open ocean, there's a strong, almost fall-like cold front moving off the U.S. East Coast. And its accompanying dip in the jet stream looks very likely to scoop this disturbance up and direct it well off the U.S. East Coast, possibly even east of Bermuda, as it heads harmlessly out to sea. So, not a U.S. threat.
Good to hear. And the second disturbance?
The second wave, which has been designated as Invest #99L by forecasters that invest just means it's being investigated for potential development, is located far out in the eastern tropical Atlantic. It currently has about a 40% chance of development over the next 7 days. However, it's facing increasingly hostile atmospheric conditions ahead. We're talking a significant amount of dry air entrainment and unfavorable wind shear. So if it doesn't manage to organize itself significantly today or tomorrow, its chances of developing further are actually quite slim.
So likely to fizzle.
Most likely, yes. In any case, there is currently no indication of that system being a threat to land. It's most likely to just die out over the open tropical Atlantic. If, by some really slim chance, it were to overcome these odds and become a problem, it would be a very long time from now, maybe in the Western Caribbean or the southern Gulf of Mexico, perhaps 9 or 10 days from now. But that's highly unlikely. And then there's one more little area of interest on the map today. A non-tropical, low-pressure system lingering on the tail end of an old cold front. It has a very short window of time, maybe a day or so, to potentially develop into a tropical or subtropical depression before it, too, is swept out to sea. again posing no threat to land. We sometimes call these low-odds lemons.
A low odds lemon. I like that. So it sounds like some ongoing activity, but thankfully no immediate U.S. threats looming right now. Does this suggest a trend for the coming weeks? Are we heading into a quieter period?
Yeah, that naturally leads us to an important question about the coming weeks for the broader tropical Atlantic. And it does look like we're probably heading into a bit of a lull in tropical development across the Atlantic basin. I would anticipate a relatively quiet stretch for the next 10 to 14 days. It's a period that could possibly extend into the first week of September.
And why is that? What causes a lull like this?
This quiet period is primarily expected due to something called subsidence, which is essentially large-scale sinking air over much of the tropical Atlantic. When air sinks like that, it warms up and it dries out. And this effectively squashes any attempts at storminess. It creates a very unfavorable environment. It makes it significantly more difficult for tropical storms and hurricanes to form or strengthen. It's kind of like having a lid or a cap on the atmosphere, preventing the deep thunderstorms, the convection needed for hurricane formation.
Okay, so a temporary cap on activity, but not necessarily the end of the season.
Oh, definitely not the end of this season. We always have to look ahead. And long-range models, including the sophisticated ECMWF weekly ensembles, they are suggesting that the back half of September could feature above-average activity again, and potentially there could be some cause for concern, especially maybe in the Gulf of Mexico later in September. So it's not a complete all clear for the entire season by any means, but a temporary reprieve does look like it's on the horizon.
That's a lot to consider, from the intricate mechanics of rapid intensification to the global reach of a single hurricane like Erin. We've gone deep today into Hurricane Erin's immense size, its far-reaching impacts across the eastern seaboard, and even potentially into Europe, and the critical role that warming oceans play in intensifying such events and influencing their very structure. It's a powerful reminder, isn't it, of the dynamic and interconnected nature of weather and climate, how what happens far out in the ocean can profoundly affect communities thousands of miles away. So what does this all mean for you, our listener? As we've seen with Erin, the influence of ocean temperatures on storm behavior is really undeniable. It affects not just its peak intensity, but its very structure, its size, its expansive reach. How does understanding these dots to connect, from the science of rapid intensification to the reality of sea level rise, how does that change your perspective on weather forecasts, and what steps might this knowledge inspire you to take? Whether that's just staying better informed, preparing your home more effectively, or maybe thinking about community resilience in a new way. It's something to think about.
Absolutely. Knowledge is most valuable when it's not just passively received, but truly understood and then applied to our lives and how we view the world around us. There's always more to learn, always. And consistently considering multiple perspectives, especially regarding our changing climate, it truly enriches our understanding of events like Hurricane Erin and how they fit into the broader planetary picture that is constantly evolving around us.
Well said. Thank you for joining us for this in-depth Meteorology Matters deep dive. We really hope it's giving you a deeper understanding of Hurricane Erin and the complex forces at play. For more insights and updates from meteorologist Rob Jones, you can follow him on Instagram. His handle is meteorologist. On TikTok, you can find him at TV Meteorologist, and find him on YouTube by following Rob Jones Hurricane. That YouTube channel, Rob Jones Hurricane, is also where you can find the Meteorology Matters podcast playlist with all our episodes. Until next time, stay curious and stay informed.